Hi, welcome to RAR Math. Today I'm doing a series of videos on parent functions and their transformations. You can see that I'm on my computer today so that I can make it a little bit simpler. Using Desmos.com, an online graphing calculator, makes all of this a bit simpler and faster. All right, my two parent functions that I'm going to use for this video are x cubed and x. Yes, y equals x is a very simple parent function. For both of them, I want to add 5 and subtract 3. All right, so let's see how this works. Let's start with y equals x cubed. So that's our parent function. You'll notice it goes down and up. Looks very lovely. Let's look at our next one, y equals x plus 5 cubed. So when I did x plus 5 cubed, essentially whenever a variable is caught in parentheses with a number, you have to set it equal to 0. And x plus 5 is 0 when x is negative 5. So the function moved over to negative 5, which means when we do y equals x minus 3 cubed, this got moved over to positive 3. Because x minus 3 is 0 when x is a positive 3. All right, so let's look what happens when we have our parent function, which is y equals x. First of all, I have students who have a lot of trouble graphing y equals x. A lot of times this comes out as a horizontal or vertical line, which is why I wanted to include this as a parent function. Y equals x, anytime you have two variables, you have a slanted line. And this is a simple one where 1, 1, 2, 2, 3, 3, 4, 4. This is what I think of as the origami line fold on your diagonal. We're going to do the same things. Y equals y plus 5. X plus 5. We didn't necessarily need the parentheses, and I hope that most of you understand that y equaling x plus 5 has the y-intercept of plus 5, but in this case, we're more interested in the x-intercept of negative 5, because that matches the intercept we had in our x plus 5 cubed. This is the same for both of them. And if we do y equals x minus 3, oops, I put in the 3, yes, we have our negative 3 for y equaling negative 3 as our y-intercept, which is how we normally do lines. But what I think is more interesting is x equaling 3 as our x-intercept, which matches our cubic. So our cubics and our lines have these x-intercepts that match because that's what makes what's in the parentheses the same. And in our original y equals x cubed and y equals x, we could imagine that as x minus 0, and that's what gave us that 0, 0. Okay, so if we come back to our original problem, it says, what does adding a constant to x do to the graph of the function? And what happens is it gives a horizontal shift. So x plus c gives a negative c shift. For any function, the graph of x plus c is obtained from the graph by a horizontal shift. This is accomplished by adding negative c to the x coordinate of each point. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.